Hi, everyone. Thank you for coming to my session. The session is about KubeEdge. The name is the KubeEdge Kubernetes Native Edge Cloud Computing Framework. This is the introduction session. My name is Inding. I work for FutureWei. I'm the one of the founding member of this project. So for my talk, I have this structure. I will talk about the background, then a little bit the architecture of a KubeEdge, then the community status. Following the slides, I'm going to give a user adoption example, and I'm also going to show a short demo to see how easy you can deploy your own KubeEdge for your use. And at the last, I have a few useful information to share with you. And I'm going to do the live Q&A after this recording. So please have your question ready. I'm going to live to answer your questions online and or in person if I can. So let's start. Background. So KubeEdge. KubeEdge is a platform we build upon the Kubernetes. So the purpose is to provide fundamental infrastructure to support network, application development, and metadata synchronization between the edge and the cloud. So all we know, cloud and edge are very different. So there's a lot of challenges if you want to resolve edge computing problems. First is network reliability. Not like a cloud, you have a high-speed, reliable connection within the servers within your data center. So cloud to edge, you may have unreliable network connections, and your network bandwidth will be limited between your cloud and edge. And also, a lot of time, the edge have only limited resource, so we need to work within that limitation. And also, when the network got disconnected, we need autonomous operations on the edge, so the edge can run independently without connect to the cloud. And also, because we support a lot of IoT scenarios, that's a highly distributed and heterogeneous device management and IoT protocols we need to work with. So that's all the challenges. So with this challenge, KubeEdge can provide four major features. The first is seamless cloud edge communication. So we do this for metadata and data seamlessly without the user interaction or intervention. And we also support edge autonomy. So basically, we support autonomous operation on the edge, even when the edge is disconnected from the cloud. And also, we are low resource ready. That means if you have only a low config the edge server, the KubeEdge can still work in this resource constraint the edge. In this situation, basically, you have a low memory, a low network bandwidth, or a very low-end CPU and low compute power. KubeEdge can work in this scenario. And also, we have strong support for the IoT. So we simplified device communication. So it's very easy for the IoT application to communicate between the application and the device in the IoT scenario. So this is our release journey. This project, we enter as a sandbox project of Kubernetes CNCF in March 2019. At that time, we already support Kubernetes core APIs, including node, pod, config map, secrets, etc. So in the June 2019, we have the official 1.0 release. During this release, we highlight some features like edge cloud coordination for devices, and also we verified container integration. The Then in 1.1 release, we provide CSI integration for the edge. And 1.2 release, a big feature we release is KubeEdge component config. In the 1.3 release, we support log connect from pod at edge. We also verify the CRIO integration. In 1.4 release, that's in August 2020, we are going to have we're going to support a Kubernetes native matrix API, so you can collect performance data from edge to cloud. And there's a few more features, because when I record this video, we haven't have that release yet. I hope when this recording is played, we are going to have this release. So I gave the release log link here, so you can click through when you see this video. So now we release every 3 months. Then about 1 month after official Kubernetes released, we are going to have the compatibility issue to solve. Then we can upgrade the Kubernetes dependency, follow the release. So we are in the same 3 month release cycle now. Architecture. So let me introduce the KubeEdge architecture. Basically, KubeEdge is natively extend the Kubernetes. So we work with Kubernetes. We may, in the majority, we have 2 components, cloud and edge. So I'm going to elaborate each part in the following slides, but now I will introduce. So mainly on the cloud, we have a cloud core. Basically, it's talk to Kubernetes and proxy the request to the edge part. The edge have a edge core and is talk to the container engine and also the MQTT devices. And I'm going to have this elaborated in the following slides. For the edge cloud part, so basically we have the list watch to talk to the Kubernetes master. We have an edge controller, basically shadow the management for the node, the pod, everything, Kubernetes native resources. And we have a device API, device controller, that's for the IoT devices modeling. Then we have a sync server. That sync server is basically we can detect inconsistent between the cloud and edge, and to solve these issues. Then we have the KubeEdge CSI drivers that hook up the storage provisioning for the edge. And also we have the admission webhook, that's for the device CRD. We can do the API validation and the best practice enforcement. Edge. So one of the important part is edge. So in the edge, we have Edge Hub. They talk to the cloud. So the cloud part of KubeEdge have also a cloud hub. So that's we set up a WebSocket from edge to cloud, so we can talk seamlessly from edge to cloud. So this way, even your edge is behind some firewall or gateway, even you don't have a public IP, we can initiate a connection from edge to cloud. So then the edge cloud can talk through this WebSocket channel to reach the cloud edge communication. And the other part, we have a metadata manager. It's a load level metadata persistent. And the HD is more like a kubelet, but it's lightweighted and only do necessary jobs. And also is also responsible for the pod lifecycle. And we have a device twin that's basically a synchronized device status between the cloud and edge and the device. The last part is event bus. That is our MQTT client that synchronize the device status from the device and the edge node. So in this way, you can control your IoT device. Community. As I said, this project entered CNCF Sandbox as a Sandbox project in March 2019. So from that time, we grow very healthy, and now we have more than from 30 to 300 contributors, and the GitHub starts from 400. Now it's more than 2,700. And for forks, GitHub forks at that time is 100. Now it's more than 700. And the contribution organization is from beginning only one, now it's more than 25. And the maintainers is growing healthy from 7 to 14. It's from 5 different companies. You can see the top contributors, the new contributors are from 4 different companies. And then we have a steady commit trend for the our repo. And also, we are collaborating with other open source communities, and the Kubernetes IoT Edge working group is very support for this project, and we have a very close collaboration with them. Also, we work with LF Edge, Linux Foundation Edge, Acrino project. We have a 2 blueprint project family there. One is called Elliot. It's mainly for industry IoT. The other one is KubeEdge Edge Service BP is a blueprint. That's for ML offloading and some AI framework. A lot of new verticals or scenarios we build. Contributions. So you can, as I said, we have a lot of contribution organizations, and also we have a lot of adopters. Contributions including ARM, Samsung, China Unicom, etc. And that's all listed here. And also we have more than 20 adopters. You can click, that's all listed in our GitHub repo. You can see we have adopters a list. And we mentioned the RaceCom, WorkCloud, Xinghai IoT, KubeSphere, Huawei Cloud, and a few others. We need their confirmation before we can publish their name. So one user adoption examples I'm going to present here is a highway ETC system. You can see we have a lot of toll gate in the highway. So that's touchless, contactless. So the car can drive through the gate. So it automatically recognizes your plate number and charge on your account. So you can pass through the gate quickly without a stop and go and pay and keep your change or something. So for this scenario, we have a lot of edge. So basically, also the edge have a heterogeneous hardware. Some have x86 servers. Some are using ARM servers in their gate. All of them, our edge node is controlled by the Kubernetes plus KubeEdge. So KubeEdge in charge of deploy the application to the edge and manage the life cycle, all this stuff. The Kubernetes and KubeEdge is deployed in the public cloud, and Edge is geo-distributed across a lot of places. So in this scenario, we have more than 50,000 edge nodes managed by the KubeEdge, and also the containers, the application containers, is more than 500,000. So, and also it's generated about 300 million data record every day, and it's improved the efficiency of this system. It used to be 15 seconds to process a car. Now it's only take 2 seconds. The truck used to take almost 30 seconds. Now it's down to 3 seconds. It's improved the user efficiency. Now give me a few minutes. I'm going to show you a demo to see how easy you can deploy your own KubeEdge system, and how easy you can use the same Kubernetes experience to deploy application from the cloud to the edge. So you may not even notice it's running on the edge. It's not in your data center. Now let me show you a quick demo. So basically, I have two windows. The upper one is the edge. The lower one is the cloud. We already have a Kubernetes deployed. You can see there's only master node right now. Now we register our cloud part. It's just one single command. You can see the cloud is registered. The cloud part is the cloud core I show in the first slide of the architecture. Now we keep a token. This token is using by the edge to register to the system. Now we initiate the connection from the edge to the cloud to register this edge node to the system. We use this token and to verify your identity. Now we can go back to, we can see the log. The edge core part is running properly. Now let's go back to the cloud. You can see in the screen, the get node, you can see the agent, the edge node already registered as a worker node in the system. Now let's do a quick deployment. Basically, we have a simple NJX application we are going to deploy. So you can see all the API and the CLI is the same as the it's all as the Kubernetes. Now you see we just do the deployment. YAML is deployed. You can see on the top you already Docker PS see the system, see the pod is running. Now and at the bottom from the cloud we access that NJX port. You can see it's responding. The NJX is running properly. Yep, that's the quick demo. So you can see from the demo, it's just one command. You can register the. Let me go back to my architecture. So you can see just one command. You can register your cloud core connect to the Kubernetes. Then it's just one command running on the edge. You set up the connection from edge to cloud, then register in the Kubernetes. From that time, you can use the native, the same Kubernetes API to deploy the application from the cloud to the edge. Even the edge is running behind some firewall. It's normally even don't have a public IP. So in the future, we are going to we in a good trend. So we are going to build our community even better. So we welcome everybody contribute and participate in our community. We are going to we are going to seek more wider user adoptions, and we are welcome and hope more developers can participate. And for the scenario, we are going to set up two SIGs. One is device IoT, one is Mac. It's a mobile edge computing or a multi-access edge cloud computing. So we hope with these two SIGs, we have more user cases and more user adoptions in this project. And we are currently applying graduate from the sandbox stage into an incubation stage. Now it's in the middle of a TCOC voting right now. Hopefully, by the time we play this video, we already formally enter the incubation stage of a CNCF incubation stage. For more technical, we have a detailed project development roadmap. I welcome everybody to go to our GitHub to see our roadmap and to give your feedback. If you want to new features, you can put in here or issue a PR in the GitHub. So this page I'm going to give you here is the first one is our official website, KubeEdge.io, and the second is our code repo. So you are welcome to go there and issue your PR to do the feature request or bug report. And any questions, you can also go to Slack. All this you can. I believe this slides will going to be shared on the website. You can come here and click here to join our Slack channel and to talk to have your questions or feature requests, anything. And also we have a Google group, so you can join our mailing list and ask questions as well. And we have a regularly meeting, basically bi-weekly. One is a Europe-friendly time, one is a North America-friendly time. You can pick up your more convenient to you. All this is in our GitHub repo. And also in these slides, you can click through. And then we have our calendars. You can click in. All this meeting, according to CNCF policy, we are recorded and published in the YouTube. So you can go to our YouTube channel to see all the meeting records. So if you have if you miss one meeting, you can always go to YouTube to see the recording and use the Slack, mailing list, any channel to ask our questions or send you a feature request. So now it's the time for Q&A. I will be here to answer any questions you have. So now I'm going to thank you. I'm waiting for user questions. I got a few questions. Let me, I just try to answer that in the order is okay. The first one is the communication between the Edge and the Cloud node, Edge Hub and the Cloud Hub. One is how the Edge node among themselves. So the question, yeah, we could put a net between Edge Hub and the Cloud Hub. So it doesn't matter. The goal we do the WebSocket this way is to make sure even you don't have a net on your edge, on your firewall for your edge, you still can communicate between the edge node and the control plane. And if you have a net, that also works. And also from WebSocket, we have TLS. We can configure TLS to do the secure communication. It won't affect if you have or you don't have a net setup. For between the edge node, we have a small project called Edge Mesh to solve the problem between the communication between edge nodes. It's still in the first stage. We are going to improve it in the second half of this year. If you are interested, you can go to the GitHub. There's an Edge Mesh folder. You can take a look. And also in the doc, there's a proposal for the Edge Mesh. You're welcome to give some feedback on the proposal. We are going to update the proposal for a more better solution. The second question is about the state of KubeEdge. Yeah, currently we are still applying graded from Sandbox. It's in the middle of TOC voting. We got 6 votes already. We need 8 to officially graduate from graduate from Sandbox into the incubation. So hopefully it's in the next few days. Technical companies. Actually, we got a few technical companies. They have a different purpose use of a KubeEdge. For example, in the China Unicom, they have their cloud offering using the KubeEdge for their IoT platform, all this stuff. And for the MEC, the technical NFV stuff, we have a MEC SIG special interest group in our project. So I'll discuss how we apply KubeEdge into the NFV or this MEC scenario. And a few technical company showed interest in the discussion. However, they are not in the production yet, but they are evaluating and prototyping the solutions. Hopefully, in a few months, I can give you a more detailed update when they agree to disclose their names and their open source efforts. The next question is ask about the edge node is a part of a cloud. Yes, from the point of view of a control plane, you can see the edge node as a kind of a worker node. The only difference is the edge node is at the remote instead of in the same data center. So as I said in the presentation, the node, because it's in the remote, you probably connect through the ISP internet. So the connection may not be reliable, and it could be slow. The latency could be large. But from control plane point of view, it's part of a Kube system. So it's just a kind of a worker node. You talk to the worker node the same way you talk to the regular worker node. However, the KubeEdge will proxy your all the communication between the remote edge node and the control plane. The next question is about KubeEdge. Why should I use KubeEdge instead of Minikube? So Minikube is a full Kubernetes deployment. So KubeEdge won't replace Minikube because KubeEdge doesn't include the all the implementation of Kubernetes. It's extended. It's built on Kubernetes. So probably the demo is very short. The demo is actually it's using Minikube. We in the cloud node we deploy Kubernetes. So to simplify deployment, we use a Minikube deployment. So the KubeEdge is add on to the Kubernetes, basically add on to the Minikube. So Kubernetes won't replace Minikube. Minikube is a kind of a very simplified deployment for Kubernetes. KubeEdge is just add on to the Minikube. So if you have a remote edge node or you want to control remote edge node, you can use Minikube plus KubeEdge as I show in the demo. So the KubeEdge the goal is to control and to manage the edge node at the remote site and to solve your network connection issues, authentication, or other deployment issues. The regular Kubernetes, including Minikube, won't solve this because they cannot tolerate the slow internet, unreliable internet connection, and also it may be it could be the edge node could be disconnected from the internet. You still need to handle the request. Another question about the demo. Oh yeah, the demo is because time limited. The question is why we show this kind of demo. Is the NJX pod running on the edge node? Yeah, I don't have time, but I can show you later. Is the NJX pod is running on the remote edge node. So the demo is show two purposes. First one is very easy to deploy a KubeEdge onto the existing Kubernetes deployment. And the second purpose is after deployment, you can easily using the existing Kubernetes API or kubecontrol the way exact the same as Kubernetes to deploy your workload to the remote edge site. And I didn't have time to show how we do the edge devices. However, I can, if anyone interested, you can go to the our GitHub. We have an example folder. There's a kind of examples If you have any questions, you can go to Slack to ask, and I'm happy to build more demo videos to show. Let's skip the next one. The question you can ask here. I suggest that if you have a more technical question, ask in the Slack. That you get a more detailed answer. If you ask here, it gets lost after this session. I won't have access, I believe. Another question is about the Quick and the WebSocket. We are evaluating the Quick, maybe replace WebSocket. That's just our technical debt. We are trying to evaluate which one is better. The last question about the what's the best developer edge application with KubeEdge? How to responsibilities between cloud and edge. So our principle is it depends on your job, right? So the edge cloud computing, the purpose, the goal is to compute and process data near the location that the data is generated. So that means if you have a lot of IoT devices, for example, you have a lot of IoT devices, you collect a lot of data. So in order to process, you don't want to transfer all this data back to your central cloud to process that. It's a waste of bandwidth, and there's also the latency, the response latency will be long. So that's why you want your processing job on the edge side, so you can have an instant result to process data. Also, the data privacy. For example, if you are a manufacturer factory, you don't want to upload your raw data back to the cloud in case there's a security issues. You don't want to, expose your data to the public. So if you can mask the data on the edge, so then you can, even there's something wrong with the cloud, you won't have issues. So basically that's two, so when you try to split the responsibility to the cloud is if you have a pre-processing for the privacies, do it in the edge side. If you want low latency then you do it on the edge. Also, if you want to save bandwidth, do it on the edge. However, if you have a large machine learning or a job, you have a energy consumption, it will consume a lot of energy on the compute, or you need a large computer resource, that job should run on the cloud. But you can, at the edge, you do the low latency to save the bandwidth and also to save your privacy. I think that's all. Okay, that's a. This last two questions is, sorry, there's the last two questions is what's the update component? That's one. We're still working on that in the community. We try to produce a better upgrade plans. And the last question is about, can we manage a remote cluster node? Currently, no. We have only one control plane. We compare if we want a remote cluster on the node. So we evaluate the scenarios. So far, we think we treat the node individually. However, we are going to introduce edge mesh to allow the node to communicate between each other. Because if you allow the cluster in the node, you need to synchronize not only the node status, but also cluster status between the master class and the small the remote cluster. That one we evaluated. We think probably, for example, in the production example I show in my presentation, they use multi-clusters. However, it's more like a kube-fed to do the layered cluster in the cloud side instead of in the edge side. So that way, we don't want to. We have a trade-off between the complexities and the simplicities. So far, we only control the remote node. However, you can allow the node to communicate to each other from your application. Okay, I think that's all the questions I have today. Thank you, everyone. Thank you to attend, to listen to this presentation. And yeah, if you have more questions, please go to the Google group and the Slack. I'm happy to answer more questions there, and I hope everybody can. I thank everybody showed interest. I hope you can have a chance to try it and probably to participate in our community. Thank you. Yeah, thank you, everyone.